everyone. In this we are going to have a series of sessions based on the chapter electrolysis. Okay, electrolysis is a very important and very interesting chapter, and you are going to definitely enjoy as we journey through this chapter. Here we go. So we start off with the definition of electrolysis. Okay, what is electrolysis? What does the word electrolysis mean? In Greek, lysis means to break. Okay, so the meaning of lysis is break, and chemically we call this break as decomposition. Okay, so and the word electro means in the presence of electricity. Okay, so this electrolysis means to break down a compound in the presence of electricity. So we move on to the definition here. So this definition is made of 5 parts rather. Okay, the first one that we already saw, it is the decomposition of a chemical compound. Okay. The second one, what is it breaking down into? It is breaking down into ions. So that is the second thing that we see. The third one, in what state should it be in order to break down? It should be in aqueous or molten state. So the compound should be in the aqueous. Aqueous means addition of water and forming a solution, or you melt the compound. So it is in the aqueous or the molten state. It breaks down into ions. Now the word electro, in the presence of direct electric current. That's not all, because it breaks down and then it has to go and get discharged as neutral atoms. Where would it get discharged? It would get discharged at the respective electrodes. So all these things have to be there in a definition for electrolysis. So we have 5 points: decomposition into ions in aqueous or molten state, in the presence of direct electric current, and gets discharged as neutral atoms. So that is the definition. Alright, we move into a big thing. Now if you are going to get a bike, first of all you must know, bike or car, you must know where the accelerator is, what is a steering wheel. If I don't know anything, I'll just go and dash. Okay, so just like that, we need to know that the basic thing for this, the terms and terminologies are very important, and the first one that we have is the electrolytic cell, in which electrolysis happens. And the other name for this electrolytic cell is voltmeter. A simple electrolytic cell is what this is. Okay, so an electrolytic cell could be made of glass, it could be made of any compound or material which will not be attacked by the chemical compound that is inside. So it shouldn't be attacked, and that is called as a electrolytic cell. So generally it's made of glass, or it could be made of silica, any material unaffected by the chemical compound. Okay, that is an electrolytic cell. Alright, the next thing that we have there is, you have 2 rods. Okay, they are called the electrodes. We will be dealing with this in detail later, but as of now we should remember that there are 2 kinds of electrodes. One is the anode and the other one is the cathode. Now what's this anode doing? It's getting connected to the positive terminal of the battery, and the cathode connects to the negative terminal of the battery. So this is to the positive terminal. Automatically, if anything connects to the positive terminal, it is positive in nature of the battery. And the cathode connects to the negative terminal. Alright. The next one, of course, in physics you would have learned that any electrical circuit will have a battery and there will be a bulb, there could be an ammeter to measure the current, all that is part of the circuit. But we also have something in this electrolytic cell, and that is called the electrolyte. So that's the next one that we see. It is the electrolyte. So what is this? This is what this chemical compound is about. And in what state it should be? Either aqueous or molten state. And it should be a compound which is capable of breaking down into ions. So now we will move on to the different types of electrolytes. Now that we have finished the definition, we move on to the different types of electrolytes: strong, weak and non-electrolyte. We should find out which one is strong, which one is weak and which one is a non-electrolyte. Now the differences being, when it is a strong electrolyte, I said it's a chemical compound, okay. So what has to happen is lysis, it has to break down, and breakdown is dissociation. The other word for breakdown is dissociation. So for a strong electrolyte, it is a complete dissociation. So the dissociation is complete when it comes to a strong electrolyte. Okay. When it goes to a weak electrolyte, the dissociation is partial, means half and half. It doesn't break down fully, but it breaks into 50%, which means there is a mixture of molecules and ions. And a non-electrolyte will have no dissociation. So that is the first thing that we learn about this. The second point is, what is it breaking down into? Again, going back to our definition, it breaks down into ions. So this is almost completely ions. Okay, for example, if you take sodium hydroxide, it breaks down into Na plus and OH minus. So this completely ions are there. Here it is partial, therefore you have molecules and ions. So when you take an example like acetic acid, it breaks down into acetate ion and hydrogen ion. But you will also have acetic acid molecules, acetate ion and hydrogen ion. That's what is called as partial dissociation. When you come to the non-electrolyte, there is no ions, only molecules. So this is the major difference between a strong electrolyte or weak electrolyte and a non-electrolyte. Now coming to the electrolytic cell again, when there is a strong electrolyte here, it allows a large amount of current to pass through. Large amount of current to pass through. Okay. Same thing when it comes to a weak electrolyte, because it also has molecules, lesser amount of current will pass through. But what do you think it would do with a non-electrolyte? There will not be anything, no current passes through. Current cannot pass through a non-electrolyte. Now we should know which are the strong electrolytes, which are the weak electrolytes, and which are the non-electrolytes. Usually the strong bases, strong acids, and the salts of these are all strong electrolytes. For example, we have dilute HCl, dilute sulfuric acid. These are acids. Examples, we have NaOH solution, KOH solution. These are examples of bases. Now going to the salts of these, if we see, we can have sodium acetate, or we could take lead bromide. Bromide comes from a strong acid and it's a salt of the strong acid. Okay. Then we could have copper sulfate. So what happens here? Sulfate comes from a strong acid, sulfuric acid, so it is a strong electrolyte. When you come to the weak ones, and mostly these are ionic in nature, only because of that it's able to break down into ions. When you come to weak electrolytes, most of the, let us take organic acids. For example, acetic acid, formic acid, and some of the inorganic acids too, like carbonic acid, and their salts would make weak electrolytes. When we come to non-electrolytes, which is made up of only molecules, which means they will have molecules, even when you add water, they are not going to break down into ions, but they are going to be only molecules. Example, you have all covalent compounds like glucose, alcohol, benzene, sugar solution, all these. In addition to this, there is one inorganic compound which is the most important, and that is pure distilled water. It's an exception. Okay, this is inorganic, pure distilled water. So this is the one thing that we must remember. 100% pure distilled water is a non-electrolyte. A little bit of traces of impurities are there, then it becomes a very good electrolyte. So these are the basic differences between strong, weak, and non-electrolytes. The next difference we are going to see is about the electrodes. As I told you, there are two electrodes, anode and cathode. Okay, so let us find the differences between anode and cathode. All right, as we see from the diagram, we can see that anode is connected to the positive terminal. Okay. Similarly, cathode is connected to negative terminal. Now what happens is, the electrolyte will break down into ions and it will move towards the respective electrodes. And how does it move? This is positive, so the negatively charged ions would move towards the positively charged electrode. So negatively charged ions are called anions. They migrate to anode. Similarly, cations migrate to cathode. Okay, so this is the first difference, this is the second difference. Now coming to this, it goes to the anode. What does it do in the anode? It has to become neutralized. Okay, for example, if we take an anion like chlorine, what would happen to this? It is having one electron in excess. So what it would do? It would give away that electron and become a neutral atom at the anode. So what is it doing? Loss of electron happens. If it is loss of electron, it is also called as oxidation. And where is this oxidation happening? It's happening at the anode. So anode is otherwise called as the oxidizing electrode. So it is called the oxidizing electrode. Alright. Now coming to this side. If we take a cation like sodium, it's falling short of electrons. So it gains one electron to become neutral. Gain of electron is called reduction. So this cathode is called reducing electrode. It's otherwise called reducing electrode. So these are the basic differences that we have between anode and cathode. The next thing we see is about ions. It is nothing but a similar thing, similar to anode and cathode. We have anions and cations. Now the two ions are anions here and cations here. Of course, we can take the points from the electrodes itself. This is over. Now coming to anions and cations. What is the charge of anode is positive, anion is negative. So negatively charged particles are called anions. Similarly, positively charged particles are called cations. Okay, example, we can have Cl minus, SO4 2 minus. These are all examples. Oxygen 2 minus. When you come to cations, all metals and hydrogen, so Na plus, Mg2 plus, Al3 plus, and so on. All these are cations. Of course, we also have hydrogen as a cation. Okay. Now, where do these migrate? Anions migrate to anode. Cations migrate to cathode. Okay. The last thing that we need to remember is we need to know exactly what is oxidation that's happening here and reduction. Okay. Oxidation is loss of electrons and reduction is gain of electrons. Now when I say this, I'll also teach you a shortcut method to remember this. You can remember this by the word oil rig. Okay. O stands for oxidation, is loss, OIL, and reduction is gain, RIG. So with this word, you should be able to remember whether an ion gets oxidized or reduced. So this one I read in a textbook, and I think it will be useful for all of us because I came across, I thought I'll share it with you. Okay, now we have a few more things to go in the next video.